We now turn our attention to the sum and difference of two cubes, which is a new method of factoring. Notice we have a cube plus a cube minus a cube, and you do need to have some of your cube numbers memorized. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and 5 cubed is 125. Now notice that 64 and 1 are both squares and cubes, and so that can cause some confusion. Now we have a little acronym, SOAP, which sometimes helps you. It stands for same, opposite, and always positive. Now let me show you what I mean by this acronym. When you are breaking up the a cubed plus b cubed, you have the same sign in that first parentheses. And then in the next parentheses, the plus switches to a minus, so it's opposite, and the third one is always positive. When you have a minus right here at the beginning, we use the same sign, S for same. It switches to the opposite for a plus, and the third term is always positive. So that trick is there to help you specifically for the signs of what you're dealing with. Now as you start doing these problems yourself and you recognize that you have the sum of two cubes, sometimes it's helpful to write out the pattern that this is going to factor into. A plus b times a squared minus ab plus b squared. And then replace this with what x and y, or a and b, should be. The cube root of x cubed is x. The cube root of 125 is 5. So that will become the a and the b. I will write this as x plus 5. My a squared turns into x squared. My minus ab turns into minus 5x. And b squared is 5 squared, which is 25. And that becomes the factored form of x cubed plus 125. When you are using a cube formula, this second parentheses will never break down, so it's not worth attempting to do that. If it did break down, we wouldn't be giving you the formula in that form. Now let's look at the next problem. We notice that we have cubes. Y cubed is the cube of y, 64 is the cube of 4. And the formula we're going to deal with is going to be a minus b times a squared plus ab plus b squared. You get to memorize that pattern really quickly. Now instead of a minus b, we will have y minus 4. A squared will turn into y squared. We then have a plus sign. Y and 4 are the two numbers, so this becomes a 4y, and then 4 squared is 16. And there's the difference of our two cubes. So let's do this next one. 2x is the cube root of 8x cubed, and then we have a 1. If we write this formula down yet again, a minus b times a squared plus ab plus b squared. The more often you write it, the better you're going to get to know it. The a minus b will change into a 2x minus 1. A squared is 4x squared. A common mistake is to go 2x squared, but it's the entire 2x getting squared to the 4x squared. Plus a times b, which is 2x times 1, which is 2x, plus b squared, which is 1 squared, which is plus 1. And there you have it. In this next problem, I notice that 81 is a square but not a cube. But what I can do is factor a 3 out front, and that leaves me with x cubed plus 27. And then I've got what I need for this formula here, because this is 3 and this is going to be x cubed, and this will be 3 cubed. So this will factor into 3 times x plus 3 times x squared. I've done the same sign. Now I have opposite, 3x. Always positive makes plus 9. Now if you forget how to do this, remember that you can factor using synthetic division. Most people remember the first parentheses, but they go, ooh, how do I do that? Well, if you wanted to, you could say, here's synthetic division. I'm going to start with my 1x cubed, no x squared, no x, and 27. Know that x plus 3 will be one factor, so put the minus 3 down there, changing the sign, bring down 1. Negative 3 times 1 is negative 3, add down negative 3. Negative 3 times negative 3 is 9, add down 9. Multiply to get negative 27, add down and get 0. And here you can see at the bottom of our synthetic division the clue to us on what that last parentheses will be. So there's no excuse to forget or not have your cube formula memorized, because synthetic division will always be a backup process for you.